sort of like tablet-y type scope. Even they're not quite sure what it is, because if you have a look at the manual here, it's the 2-channel plate oscilloscope, your good test tool, or is it a table oscilloscope, which is what they've got on the box? I don't know. A table oscilloscope, plate oscilloscope, tablet oscilloscope. Anyway, it's thick as, bro. Look at that. But let's check this out, because a lot of people are interested in these low-cost scopes. I mean, $140, even though it's ridiculous the amount of performance you get, bang per buck you get in a modern, like, 4-channel, sub-$400 US dollar oscilloscope, like your regular bench oscilloscope. Absolutely fantastic. But some people, of course, still don't want to spend that much. And if you're doing a lab on a budget, I've done videos on that, then these low-cost things for $140 US dollars, this looks like to be vastly better value than the little pocket thing we saw before. So anyway, let's check it out. Hopefully this one's, a lot more usable than the last one. Actually, they're really not sure what this is. Is it a table oscilloscope? Is it a plate oscilloscope? Or is it, I just noticed, a flat oscilloscope on the bottom? Dual channel flat oscilloscope, 100 megahertz, 1 gig sample per second, 2 channels, 800 by 480 capacitive touchscreen, none of that resistance rubbish, a 3 nanosecond rise time, 240k memory depth, which is more than enough you need on a portable scope like this, no worries whatsoever. Although it does claim to have 1 gig of memory total, so it can store up to 1,000 screens plus 1,000 waveforms and, you know, stuff like that, but yeah, whatever. And 50 millivolts to 500 volts input. Well, yeah, you're not going to get 500 volts unless you get proper probes through it. Anyway, in ×1 mode, it is 40 volts rated. So, yeah, to get your 400 volts rating, you actually need to use the ×10 probe with it. So you got the external divider. Built-in 6,000 milliamp hour battery. Don't know what that is in watt hours. And standby time, a usable time of 4 hours. So they claim I won't be testing that here. It's not a bad form factor. I rather like it. Don't really like trying to get this up. It's almost impossible. Nice and neat. Fits on the bench. Don't know about the probes coming out the top. Probably would have been better on the side, but nah, is what it is. And on the top, we've got a real clunking power switch, a micro USB. Probably would have liked to see USB-C these days, but a lot of USB micro fanboys out there. We've got a 1 kilohertz test signal on here. Nice for compensating your ×10 probes. Just 2 inputs, no probe detection, of course, for $140 US dollars. You wouldn't expect it. Overload, I guess. Is that like some peak? I don't read the manual. Hang on. Anyway, this thing is a thin R&D weapon. It's anti-burn, it's humanized, it's hydromatic. Why, it's grease lightning.
Hydromatic. Ultramatic. Why could be grease lightning?
And it comes with 2 switchable ×10 probes, supposedly 100 megahertz. You know, they seem okay. Remember, this is $140 delivered with probes. Wow. And as with the previous one, the manual's a bit how you doing. Anyway, I can't find anything about what that overled is. Li Xiaoyu's graphic display function. What? I don't know. Is that some sort of new method? Anyway, this is a flat panel oscilloscope. Yeah, they could stand to improve their manual. But anyway, it looks to be, of course, a vastly better user interface than what we got on the previous little pocket thing, as you'd expect, with a, you know, a large 800 by 600 touchscreen display. And yeah, they got, you know, analysis of common problems and stuff like that, common circuit test methods. And they've tried to sort of, you know, crystal measurements, exactly like we got before, I believe. Okay. Anyway, enough mucking around. Yes, I will do a teardown, but let's turn it on first. It's the 1013D, by the way, for those playing along at home. And Fnirsi, and that boots up pretty quick. I like that. Sorry, I'm going to have to fix the glare. Unfortunately, it's very glary. You can see my camera there with my microphone and whatnot. There we go. If I move it over here, I've got mostly wall reflecting off the background there. But let's have a look. Yep, I thought we might be able to move them, and we can. Just drag the waveforms. So that's pretty neat. So there's the interface that we had before on this thing, and left a lot to be desired. This one's much better. It automatically defaults to your peak-to-peak and RMS and frequency and stuff on there, so that's really quite nice. Channel 1 and Channel 2, they almost physically line up. 10 microseconds per division, like it would have been nice to have at least some manual controls, but if we want to change, I mean, we can, I presume we can pinch. No, well that's disappointing. I expected to be able to expand the time base. Instead, all I get is moving. So that's hugely disappointing. Move fast. Gotta go fast. Like, how do you change the time base? What? I want to click on that. Wait, how do I change the time base? Channel 1. Okay, there we go. We can pop down the Channel 1 menu. Channel 1 off, on or off. Open FFT. Okay, so you turn your FFT on from your channel menu. Okay, well, nothing popped up. Coupling, AC or DC coupling, and the probe mode ×1, ×10, or ×100. So that's handy if you did have a external ×100 high voltage probe. So yeah, with 50 millivolts per division minimum, then like on ×1, then really you're not going to be able to get really low level stuff on this. So of course I haven't read the manual because you shouldn't have to. You should just be able to turn on a scope and it should work intuitively. And sure enough, you know, you tap on channel 1, but how do you change the volts per division setting? Like, I can't pinch and zoom, but I haven't figured out how to change the time base yet. And once again, I haven't figured out how to change the vertical. Let's have a look what's in the menu. System setting, pitch and view, waveform view, USB connection. Okay, not too concerned about that. Grid brightness. Okay. Baseline calibration. Like, it looks like these controls over here are permanently here. And like, okay, you've got run and stop up there. Why you just wouldn't have it over here, I don't know. But okay, I've plugged my probe into the 1 kilohertz. Let's try our auto set, shall we? Oh, by the way, you can hear the relays clicking, which is nice. It's got input relays. Wow. Really? It can't even auto set a 1 kilohertz calibration signal. Are you kidding me? Wow, that is a complete and epic fail. Oh, I had so much hope for this thing. Oh, I figured it out. Look, just by bumming around. Control volts plus minus. Well, you know, it's easy once you know, but gee, okay. Channel 2, geez, you can barely even read that it says channel 2 there. Hi. Yeah, the reflection's just bad in the lab here because of the angle of the bench and the lights and stuff like that. But the screen is really quite nice. We got trigger menu, auto trigger, signal. Like, why do they split the words up like that? That just looks ridiculous. Normal, single, or it's just no. That's just triggering channel 1. Let's try auto setting. Auto set works, but you've got to select the channel 1. It can't auto do across channels. Okay, but it should have zoomed in more on that, but oh, there we go. Hey, it auto set differently this time. Wow. Hopefully you heard the relays there. So why it didn't choose that time base to begin with? I don't know. Inconsistent auto set functionality. Anyway, has set the trigger to the middle. So we can actually adjust. How do we adjust our trigger level? Can we just drag? I'm dragging it down. Look. And it springs back. Why? It's like an auto 50% trigger level and it always chooses, you can't override it. What? Maybe you can do it in normal mode, perhaps. Let's go to normal mode. There you go. Yep. Is that the same as the other one? Yeah, you've got to choose normal trigger mode in order to set the trigger level. That's not how other oscilloscopes work. That's just wrong. And really, for single shot mode, like, I would like to see like a single shot button here, like run stop single, like cursors, like bury those away. Okay, so we're running now. You can see it updating there. Why it can't get the frequency of that? Like, why? That is the easiest signal possible to get a square wave like that. We got more than enough divisions on the screen. Anyway, if we stop it, right, the thing is we've got 240K points of memory. It looks like it's got some data outside the screen. What, got 2 screens worth or something like that? But 240k points is a, fairly decent amount of memory for a scope, especially for this price. It's more than adequate for most tasks, and I still haven't figured out how to use the horizontal time base. Why am I flatlining? Is my signal suddenly vanished? I'm a continuous 1 kilohertz signal. Move fast, move slow. It's what's this ripple on the top? What is all this garbage? Like this is some sort of aliasing. So 8 here, the time base increases the key area. That is, the waveform is pushed horizontally. The strict area to the left of the center line is the key area. What? I got it. Look, you got to tap over here on this side, 200 microseconds per. Wow, it doesn't even respond properly. And tap on this side, is it? So it's going up in your time base, but it doesn't always respond. And then tap on this side of the screen, presumably anywhere, but it doesn't respond most of the time. Wow. And I'm in fast mode. Don't move. I seem to be in a sweet spot, am I? Here we go. Here we go. Oh, why is it? Whoa, did you see that? That waveform shifted. Wow, this is terrible, Muriel. Okay, it seems to be reacting now. Why it wasn't doing it, and then, yeah, it's some aliasing thing. Okay, now it seems to be operating okay. Either side of the center line there seems to do it. So if you accidentally touch it, you're going to change your time base. But anyway, look, right, let's assume we've got a 240k memory. Let's stop, and then, oh, there we go. We can zoom in. Okay, there we go. Great. And then we can, oh, look, we can't zoom in and see the rest of the data. That is ridiculous. Why? It only allows us to shift like 2 screens worth. But I can go up like that, okay, because that's the data we sampled. When you zoom in, you can't then scroll through the rest of it. Why? What sort of limitation is that? That's just nuts. That's a real shame. It's a decent usable amount of memory. No, I just don't like this at all. And how do you reset your horizontal? I just don't know. You just got to drag it, I guess. Oh, whoa, did I get rid of it there? No, just got to drag it back to the middle, I guess. Ugh. And I'm getting, once again, much more responsive control out of it now, so I'm not sure what the deal was before. But anyway, yeah, look, yeah, we're not exactly centered on our thing. And if you try and drag it that way, it just drags the entire waveform, really. So, ugh. And also, there's something very strange with the 1 kilohertz test signal. It is not from ground here. And yes, I have verified this on benchtop scope, and you put it in AC mode, it doesn't automatically change. You've got to get out of the menu, and then it goes into AC mode. But yeah, I just don't like how it all shifts around. Unfortunately, one of the problems is the limited volts per division up here, and this is as low as we go. So I'm feeding in a 1 volt peak-to-peak signal, and that's the best we can get. It can't go any further than that. So yeah, this is not for low-level signals. And the single-shot mode is just like silly. I mean, auto won't even update while you've got the menu on. And you just, because you don't have a dedicated single shot button over here, you go there and it's stopped waveform updating. So you can go into single and it doesn't I think it just might have updated then. You saw a bit of waveform change over here, but yeah, it's usability just leaves so much to be desired, really. And then if you go into measurement here, you can choose channel 2 and channel 1. Why it's like swapped like that, I don't know. It doesn't match everything else. Bit crazy. Anyway, you can turn on various things and it will add them down to the bottom here. So that's kind of cool. But unfortunately, they're not transparent, so it overlays your waveform. And I do believe you can just save pick like that, so you can just screenshot it and it will save it internally. It should appear as a drive when you plug in the USB. And it's got a similar picture view and waveform review. It's like these are just different screenshots, so you can actually call them up like that. It's a bit rudimentary, but it's there. Okay, so I'm just doing the baseline calibration here before I do some more performance tests on this thing to see if it really does have 100 megahertz bandwidth, because if you saw last time, it did, but there were a lot of issues with it, so still going. Okay, I've been waiting for like 5 minutes or something. This is getting ridiculous. I think it's locked up. Okay, so we'll test the bandwidth with a 50 ohm load directly on it. We're in ×1 mode here. At 1 megahertz, we're getting our 2 volts peak to peak. So we're looking for where it drops to 1.14 volts. And if we go up, let's change the time base. It's not doing good. All right, let's call that about 22 megahertz. So the claim of 100 megahertz is absolute BS, of course. If you read the manual, it says, oh, you've got to use the ×10 probe, blah, blah. And it doesn't matter, by the way, whether or not you have it on ×10 position. That's just going to change your scaling down here. The front-end analog bandwidth, direct signal in, is only 22 megahertz, 3 dB down. And they give you a solemn reminder, the bandwidth of the ×1 probe file is 5 megahertz. Yes, I've actually done a video explaining why ×1 probes only have under 10 megahertz bandwidth. The bandwidth of the ×10 probe file is 100 megahertz. When measuring higher than 5 megahertz, you need to turn the switch on the probe to the ×10 position oscilloscope. Otherwise, the signal will greatly attenuate. This is the case with oscilloscopes. Blah, blah, blah. Okay, let's try and calibrate this thing. So I'm feeding in a 1 kilohertz square wave. I've got a 50 ohm terminated load here, and I'm using a proper BNC adapter. We're on ×10. I'm using the supplied probe, so everything's hunky-dory. I've given a tweak at the correct tongue angle, so we should be ready to go. And we're supposed to be 3 volts peak to peak. We're getting 3.2. Yeah, okay, let's just run with that. I can't get any better. It's just, that's what it is. And check this out, we're getting the same interleaved sampling problem that we're getting on this, because this thing did not have the claimed 500 meg sample per second sample rate. And I think when we do a teardown of this, we'll find this one doesn't have the claimed 1 gig sample per second either. And that's how they're getting away with the cheap price. It is not a true 1 gig sample per second as they claim down here. Anyway, I'm now feeding in 5 volts peak to peak at 100, well, that's 100 megahertz. Okay, look at it going silly buggers. If I go to 101 megahertz, it's nice and stable. If I go to 100, it's weird ass. If I go down to 99, it's stable. Look at that. So there is some interleaved sampling weirdness going on there. Whoa, we've got some peak there. Look at that at 50 meg, 60 meg, go down, 40 meg. It's just, yeah, it's all over the shop. That's terrible, Muriel. That is just weird. Go to 100 megahertz, and yep, that's the fastest time base we can get it, and it does not like that at all. Yet go to 101 megahertz, and we at least get our sine wave, and then it will eventually taper off. No. This thing just, it's just ridiculous. It's almost a joke. And if you want to look at the ALIS in, we're at 101 megahertz here, the fastest 10 nanoseconds per division. Can't go any faster than that. We go down, it's okay. We go there, Kamagutsa, and then of course it's the wrong frequency because there's our ALIS in. So, yeah. And I'm at 43 megahertz, even though it's showing only it shows 43 occasionally there. And watch this, if I jump up to 44, boom, look at that amplitude difference. And that's exactly what we found on the Pocket one too. It had the weird-ass response, no, it's not my SIGGEN, and it's been confirmed with direct coax connections and all sorts of stuff. So, you know, it's not the probing system, it's the scope front end itself. The little Pocket one worked exactly the same way. So I think when we do a teardown of this, it's going to be almost the same sort of front end and sampling system on this. They've just got a much nicer GUI touch interface. And yeah, it exhibits that same weird thing at exactly 100 megahertz that we saw on the other one. 99 megahertz, 100 megahertz. It just comes a gutser. We're in auto mode, 101 megahertz, works fine. If we go into normal mode, it'll do exactly the same thing. Just comes a gutser. Yep, there's some interleave sampling. This is not 1 gig sample per second. Yeah, you'll find this is much lower. It's doing interleaving sampling, and it's not true real-time sampling rate that we've been used to in modern scopes for the last 20 years. This is how they're getting the cost down. So inside this thing, we do actually have some changes. Check this out. We've got an Altera Cyclone 4 here. We've got an internal micro SD card slot. So that'd be nice if that contained the firmware, but I suspect it might just be the waveform memory, stuff like that. So whereas before we just had an ARM processor in the thing, but in the rest of it, there's our battery up there. So you could actually fit this with a larger battery if you wanted to, you know, increase the capacity. That'd be nice. So one of the other major changes is, of course, we've got a dual ADC down here. Now, once again, looks like they've rubbed the numbers off this thing, but somebody did some reverse engineering on the previous Pocket one, and it was an Analog Devices AD9288. So yeah, it was nowhere near the sample rate that they were claiming. So what are they actually running up here? They've changed it. Aha, that's an all-winner ARM processor, the F1C100S. I'll try and put up a data sheet for that, but yeah, they've changed that from the ST ARM that they had before. So that's controlling the LCD interface. You can see that there, and they've just got, you know, like an 8-bit data interface or something going over to the Cyclone over here, which is the acquisition engine. So as you can see, the ADCs, can't see any markings on those at all. So the front end here has certainly changed from the previous one. I'll put up a side-by-side shot here of the old Pocket one. This new one actually has 3 mechanical relays here, and it doesn't have the whole bunch of switching trannies that we saw before. So they have actually changed that, but I suspect that the ADC is exactly the same as they're using before. But yeah, it has changed. Unfortunately, the front end seems to still have that weird peak in it, and it's, look, no, this thing's like a 20-30 megahertz scope. All right, let's probe the clock on this thing. Let's assume it's an AD9288 or clone equivalent. So that's pin 47 over here. And pin 47, there you go. Wah, 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 wah. That's 100 megahertz sample clock. It's got 2 different clocks. One, it's a dual channel 100 meg sample ADC, because this is supposed to be a 100 meg sample ADC, assuming it is that exact one. But anyway, it is running at 100 meg samples per second. There are 2 different clock lines here because it's actually a dual channel ADC. And yes, I'm on 10 nanoseconds per division. I'm on the highest sample rate. And if I change that, we'll see the clock change. But we've already done that on the Pocket one, and it's exactly the same thing. So yeah, they're lying. This is not 1 gig sample. Well, it's 1 gig sample effective sample rate, or equivalent time sample rate, as they used to call it back in the old days. But yeah, ever since the Tektronix TDS 200 series scope, what was that, 25 years ago now or something? Oh, geez, it's got to be pushing that. They were a genuine 1 gig sample per second for 100 megahertz bandwidth, 10 times higher sample rate than analog bandwidth. And yeah, no, this is not a real-time scope. This is why it's useful for pretty much anything over like 20, 30 megahertz, something like that. Yeah, I mean, you've got to have a really good triggering system to try and get equivalent time sampling. And of course, your really ultra high expensive high bandwidth scopes, like your 20 gig bandwidth scopes and things like that, they'll usually operate on equivalent time sampling, but they've got spectacularly good trigger systems and everything else. And this thing, no, it's just built down to a price. We've just got an all-winner processor. We've got an Altera Cyclone for FPGA here with the sample memory in it, and just some 2 cheap, possibly clone 100 meg sample per second ADCs, and they're trying to do interleave sampling on this, and they're just coming a gutser. But it's actually going to be 200 meg samples per second. Why? Because each one of these ADCs is a dual 100 meg sample ADC, and they've got 2 separate clock inputs. One's on this side and one's on this side over here. Here's the analog input. So if they're driving both clocks here, you could actually drive them out of phase to each other, so that you effectively get a 200 meg sample per second ADC. You've just got to feed the input channel into both, and sure enough, here is the output of this op amp up here, which drives. That just looks like it's jumping under there. It's going across here, and it's going through this resistor here into, you notice, one of the inputs here, and Sure enough, one of the other inputs here. So they are driving and using both channels of that ADC. It does seem to be an identical pin out to the AD9288. But you can see that the other one goes over to this channel here. So yeah, they're, you know, in theory, they could actually combine the two if you went single channel, but I don't see them doing that whatsoever. So I'm feeding in a 1 megahertz signal here into channel 1. I've turned off channel 2 just to see if it can actually use all 4 ADCs on the one channel, but no, it can't. It's physically, you can see it, it's not feeding. I've got a 1 megahertz test signal there, it's there, but it's not on the other ADC input chip. So they're not linking the signal from one channel to the other to utilize both ADCs. So, yep, sorry, 200 meg samples per second, real-time sample rate, that's it, per channel, so that's all right. And look, I won't even bother and go in and check out the FFT and other, you know, little functions and things like that. It's like, man, this thing is really built down to a price. You're getting exactly what you expect from a $140 US dual channel portable scope like this. You get what you pay for. It's built down to price. You're not getting your true 1 gig sample per second, so you're not going to get your true 100 megahertz bandwidth, and the front end's a bit how you're doing in its response and performance and stuff like that. No, this thing, once again, just like this Pocket One here, it's a bit of a toy, and well, just like this Pocket One, for twice the price, you do actually get 2 channels and 200 meg sample per second channels. So as long as you limit this thing to say, you know, say it's like 20 or 30 megahertz bandwidth, then it's probably okay, but it's got like software issues. It's like the triggering things and automated frequency doesn't work properly. And they actually tell you that in the manual of how to get around it and make it work and things like this. And it's just, the hardware's fine. Like, I really like the form factor and the user interface is okay. Yeah, it's just got no spit and polish whatsoever. It's really good base hardware for like a dual channel portable 20 megahertz scope. It's pretty fine as long as you don't want to do low signal measurement, and maybe if somebody could come up with like an open source software for it to make it, you know, a bit better and stuff like that, that'd be nice. No, it's disappointing. I expected them to add more spit and polish to it over the Pocket One, but obviously they couldn't do that for the price, and you really don't expect it. You can't expect miracles for $140 delivered. It is what it is, and hey, it's a kind of a real handy tool if you're after like a dual channel portable little 20 megahertz scope, and if you've only got sub $150 to spend and you want a scope, it, you know, if you're a beginner, it's probably going to do all right. So yeah, as long as you don't expect much from it and you get to know its you know, quirks and limitations and things, then it's a neat little tool. Anyway, thank you very much, Fnirsi, for sending that one in. I mean, like, as an oscilloscope, you can't give it a thumbs up as a recommended thing, but as always, bang per buck. Is there anything else on the market for $150 in a portable form factor like this? So yeah, you've got to make up your own mind whether or not, you know, this thing is suitable for your needs. And certainly if you only got $150, well, there might not be anything better. You can maybe argue like a PC-based scope perhaps might give you better performance for that sort of low-end price. But then again, doesn't have a nice little compact form factor, battery-powered touchscreen, 7-inch jobby like this. So yeah, it's certainly an interesting option. I'll link in Fnirsi's AliExpress store down below, because it's amazing what you can get for $140. You would have killed for this 20 years ago. Yeah, a bit more spit and polish would have been nice, and just don't even market it as 1 gig sample per second, 100 megahertz. It's just ridiculous to even try that. You know, people would be happy if this was marketed as a dual channel 20 megahertz, 100 meg sample per second thing with, you know, all the battery powered and the touch screen and a bit more spit and polish in the user interface, and it'd be a total winner. So yeah, anyway, let us know your thoughts down below. It's an interesting device, $140. Anyway, hope you enjoyed it. If you did, give it a big thumbs up. And as always, discuss in the comments down below or over on the EEV blog forum, where I'm sure everyone will be talking about this thing and, yeah, like analysing the hardware and stuff like that. I'll post some high-res photos over on the EEV blog forum thread for this one. So anyway, hope you liked it. Catch you next time.